Viewers, in this video we'll see the implementation of Boolean function using the decoder. Example 2. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. We need to implement the Boolean function using the decoder. The function given as f of w, x, y, z. These four inputs equal to sum of min terms 1, 3, 5, 6, 11, 14 and 15. 1, 2, 3, 4, 5, 6, 7 outputs are available. We know that decoder is a device having n input and 2 to the power n output, right? So here 4 inputs are available. So n equal to 4 and 2 to the power 4. That is 4 input and 16 outputs. So here 15 is available. Definitely we need 16 combination of outputs, right? So we need to use the decoder 4 inputs with the 16. 4 into 16 decoder. 4 inputs and 16 outputs. In that we will get the 16 different outputs. We need to connect the required outputs. Only 1, 3, 5, 6, 11, 14 and 15 can be connected. This is the sum of min terms. So we need one OR gate. All these inputs are connected to the OR gate. So that OR gate will add all this required min term and give the final function f, Boolean function f. Now we'll see the diagram, logic diagram. So this is the 4:8, 4:16 decoder. A, B, C, D 4 inputs. Here given as W, X, Y, Z. W, X, Y, Z is a 4 inputs. We'll get the 16 different outputs are available. 16 possible outputs will be available, right? Now we'll see how we'll get the output. So based on this value, there are 4 digits available. So there are 16 combinations. 2 to the power 4, 16 combinations. 0, 0, 0, 0, 0, 1, like that. For every combination, we'll get the output, right? For example, 0, 0, 0 means here y naught will be 1. So this is input. This is output, right? So w, x, y, z, that is w, x, y, z is 0, 0 means y1. Here the output will be 1. Other terms are zeros. All other terms will be 0. So the corresponding min term is here 0. Then 0, 0, 0, 1 will get here 1 as the output. 0, 0, 1, 0. Here 1 as the output. Other terms are 0. 0, 0, 1, 1. 1 as the output. Other terms are 0. Then 0, 1, 0, 0. 1 as the output. 0, 1, 0, 1. 1 as the output. 0, 1, 1, 0. 1 as the output. 0, 1, 1, 1. 1 as the output. So and next term is 1, 0, 0, 0. 1 as the output. 1, 0, 0, 1. 1 as the output. 1, 0, 1, 0. 1 as the output. 1, 0, 1, 1. 1 as the output. Right. The finally it is 1, 1. 1, 1, 0, 0. 1 as the output. 1, 1, 0, 1. 1 as the output. 1, 1, 1, 0. 1 as the output. 1, 1, 1, 1. 1 as the output. Right. So this is the 16 combination. Based on that we'll get the output. For example, w, x, y, z is all are 1 mean y15 will be 1. All other terms will be 0. That is the basic function of the decoder. Only this output is 1. Other outputs are 0. Similarly y14. 1, 1, 1, 0. W, x, y, z is 1, 1, 1, 0 mean this y14. This pin will be available with the 1 as the output. All other terms are 0. So this is corresponding to the min term. This is 15, 14, 13, 12, 11. So what we need, that alone can be connected, right? So what we need is 1. We need 1. So 1 is connected. Then 3 is connected. 5, 6, then 11, 14 and 11, 14 and 15 are connected. So the required terms are connected. So 0 to 15 output is available. Here 0 available, here 1 available, 2 up to 15 available. But what we need is 1, 3, 5, 6, 11, 14 and 15. Only these 7 inputs are connected. This 0 is not connected, 2 not connected, 4, 7, 8, 9, 10, 12, 13 are not given in the minterm. So that is, these outputs are not connected. Only required 7 outputs are connected. So this OR gate will add all these 7 inputs, 7 outputs, and will give the final Boolean function, right? So in this video we discuss how to implement the given Boolean function using decoder. We are use the 4 input with a 16 output, 16 different output. Based on the 4 input values, that is 0, 0, 0 or 0, 1, 0, 0, 1, 1. Like for that, we are getting 16 combination of output. In that, the required terms are connected using OR gate and will get the final Boolean function. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.